Welcome back everyone, and now let's talk about open close principle. The definition of open close principle is it is open for modification and closed for extension. So what is meant by this? So let's understand this by some of the examples. Open means change the existing system or extend the behavior of existing system, but without changing the existing code, because when you change the existing code, then there are high chances that you will end up producing the bug in your system. And when you change the existing code, then definitely you have to run your test cycle again on those parts which are already tested, right? So the quality of the good architecture is that it should not allow to touch the old modules which are already tested or which are already in production, right? So the change should be on low risk. So we will see some of the code examples where we are violating that principle, and then we will see that how we can write open close compliant architecture. And at the end, I will let you know that what are the best use cases where you should use open close principle, and what are those use cases where you should not use that principle, because if you use that principle over there where it doesn't fit, then you will end up creating a complex or over engineered system. So let me open Visual Studio and I build a very simple example. Here I am offering the discount on the basis of the type of the customer, right? So for example, if the type of the customer uh, change, or if there is any new modification in that piece of code, then definitely you will modify that class which is not meant to be modified, right? And this logic which is in front of you is tightly coupled, and it is making no sense, because I'm working on a lot of hard coded type of code over there, right? So this is clearly violation of open and close principle. So let's see the refactored form of this code. So let me open this open close refactored code. So here I have created an interface and created different classes for each discount type. So for example, if there is any change in existing discount type, then it will scoped to its relevant class, and it will not change rest of the other pieces of code, right? Or for example, if there is any modification or new discount type is introduced, then it will not change any existing code at all. So this is the way you can write open close compliant architecture. You can also implement factory pattern over there, which will also be open close compliant architecture. So whenever you're working on the strategies like this, then you should apply the open close principle in your code. So let's move back to our presentation again, and let's see that what are the best use cases for the open close principle. So let me move further. So one use case is whenever you are writing the payment processing logic, and you need to implement a different type of payment gateways, just like Stripe, PayPal, or any other gateway, right? Or if you are offering different discount as we saw in our demo, or if you are uh, working on authorization and authentication policies, then you should apply that pattern. If you're working with the logging and monitoring, because there are different types over there also, then you can apply that pattern as well. And if you're working with the dynamic reporting, then that will be suitable pattern. And if there is any notification system you're trying to build, then you can apply that open close principle. And if there is any tax calculation, so you can apply that principle over there also. So there are so many other similar type of scenarios where open and close principle you can apply. So where you should not apply that open close principle, so when you're working on simple CRUD operations, if you apply over there, then you will end up creating an over engineered system. Or you should not use one time use cases where you feel that there is no any frequent change, right? Then you should not use that. So when you are working on a business rule which are defined by external system, then open close principle is not suitable in that scenario as well. But how we will identify that open close principle is not a suitable choice? Then there is one rule of thumb. uh, if requirements are unlikely to change, avoid over engineering with OCP. So I hope you understand that how OCP principle functions, and in our next demo we will see that how the Liskov substitution principle works. Thank you very much.